Today we're looking at section 510 and 511. 510 is on special products of binomials. The first special product we're going to look at is called difference of squares. So if I'm multiplying out x plus 3 times the quantity of x minus 3, I multiply just like we're doing our regular double distributing. X times x would be x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. And positive 3 times negative 3 is negative 9. Now when I simplify that and combine my like terms, the negative 3x and the positive 3x negate each other. So I end up with x squared minus 9. Notice y times y squared, y times negative 7y, positive 7 times y is 7y, and positive 7 times negative 7. Again, same situation. Negative 7y, positive 7y, they negate each other, and we're left with y squared minus 49. All right, I want you to start looking for a pattern here. Every time I do one of these, I can predict, well, it's not really predicting, that when I have m plus 4 times the quantity of m minus 4, I'm going to end up with m squared minus 16. Because I know those two middle products will be negated. T squared minus 25. So what ends up happening is my inner terms and my outer terms, x times negative 3, negative 3x, and 3 times x, 3x, end up getting canceled out because they are additive inverses. So let's look at this. This is called a difference of squares. This happens when I have the same terms in both binomials, a and b. The only difference is my signs are different. My signs are different. So in this case, this is a sum and this is a difference. So whenever your terms are the same in both binomials, but your sign is different, opposite, you will get the first term squared, the second term squared, and it's a subtraction sign. So that is the pattern. All right. So remember, we call this a difference of squares because it's a perfect square minus a perfect square. So it's a difference of perfect squares. It's also very important that you get to know the name of this when you see this type of pattern. You have to know that it's called a difference of squares. So make note of that. All right, so now you try it. I'm going to do the first one with you. So remember, we square the first term, p squared. I'm squaring the last term, 64. And because I see different signs, it's going to be a difference of squares. Now you do the next two. Stop the recording and finish 2 and 3. Now check your work. You should have gotten y squared minus 144. M squared minus 6 for number 3. 36, sorry. All right, I'm going to do one more with you, and I want you to stop the recording and then continue. So remember, on number 1, we're going to square the first term, p squared minus 4. Square the second term, 2, and add a difference sign in the middle to get the difference of squares. Now pause the recording and finish the rest of the problems. Now check your work. Number 2 is x squared minus 81. Number 3 is w squared minus 100. Now, number 4, a little bit different. I'm squaring everything in there. So, I'm squaring my 2. That's 4. I'm squaring the p. That's p squared. And I'm squaring the 3. That's 9. 4p squared minus 9. The next one, be careful because your number comes first. So this one's going to be square the first term, 36, minus t squared. Why am I getting that? Because positive t and negative t make that negative t squared. Okay? All right, next one is n squared minus 25. 9x squared minus 49. 16 minus q squared. Number 9 is 64d squared minus 1. And number 10 is 4 minus 25g squared. This is called a difference of squares. Now we're going to go to binomial squares. When I have a binomial square, I want you to remember, do not distribute that 2. A 2 as an exponent. Exponents do not get distributed. This is a common mistake that a lot of students make. So remember, when the exponent is touching the parenthesis, it means everything in the parenthesis is squared. So what x plus 5 to the second power, the quantity of x plus 5 to the second power really means is x plus 5 times the quantity of x plus 5. Now when I double distribute that, I get x squared plus 5x plus 5x plus 25. Which gives me a total, a simplified trinomial of x squared plus 10x plus 25. Now, this is a way we can keep doing, but there is a pattern here. And the pattern is when you have a perfect binomial square, we're going to square the first term, square the last term, and multiply both terms together and double them, times 2. One more time. Look at the highlighted version in blue. I'm going to square the first term, x squared. I'm going to square the second term, 25. And then when I multiply 5 and x together, so that's square the second term, it's positive 25. When I multiply those two together, I get plus 5 times x times 2. 2 times 5 times x. Here's where you get the 2 times. It's 2 times I'm going to get this same middle term. So it's twice when you multiply those two together. All right, so remembering that pattern, let's try it. Square the first term. I'm going to square the last term. And now I'm going to multiply them both together. P times 9 is 9p. Then double it. 9p times 2 is 9p times 2 is 18p. Makes it nice and quick and fast. So when we're doing lots of these, we can get them done really quick. Let me try one more. Square your first term, y squared. Square the last term, 144. Now, I'm going to multiply them both together. Y times negative 12 is negative 12y. Then do it twice. Times 2 is negative 24y. Now, what sign is that 144? Remember, when I have negative 12 times negative 12, I end up with positive 144. You'll also notice that whenever I have a binomial square with a different sign, the pattern will always be minus and then plus. Now pause the recording and finish number 3 and 4. Now check your work. Number 3, we get m squared 36. What kind of 36? It would be a positive 36. Negative 6 times negative 6. And the middle term will be 2 times negative 6 times m, which would be negative 12m. Number 3 will be x squared plus 6x plus 9. All right, now number 1, we have t squared. The middle term will be 1 times t is 1t times 2 is 2t plus 1 squared would be 1. Try one more with you. First term is going to be x squared. When I multiply to get my middle linear term, I do negative 3 times x times 2. Get negative 6x. And then negative 3 times negative 3 is positive 9. All right, now pause the recording and finish number 3 through 10. Now check your work. N squared, number 3 is n squared minus 22n plus 121. Number 4 is 4p squared. Now be careful. When I'm multiplying 2p times 7, that's 14p. Remember, I have to double that. Plus 28p for my linear term. And positive 7 times positive 7 is 49. Number 5, 25p plus 90p plus 81. Number 6, 16x squared plus minus 24x plus 9. X squared minus 2xy plus y squared. 25 minus 20x plus 4x squared. 9b squared plus 12b plus 4. Number 10, 64 okay, 64 minus 32k plus 4k squared. All right, now you're going to tell me if it is true or false. Correct the statement so that it is true. So when we have n plus 7 times the quantity of n minus 7, we get n squared minus 49. Because the signs are different and the terms are the same, true, it is a difference of squares. Okay, number 2, what do you think? True or false? And this is false. If you notice, remember, when I square my last two terms, negative 4 times negative 4 makes positive 16. So that is false. To make it true, it would have to be plus 16. Number 3 is false because I didn't double my linear term. Number 4, true statement, it's a difference of squares. And number 5 is a true statement, it's a binomial square. Number 6, false. Remember, the only time you have two terms from a binomial by binomial is with a difference of squares. We're missing that linear term. So that would be plus 14b in the middle. Since I have different signs in the same terms, it's a difference of squares. Remember, those middle terms negate each other. False. We're going to need that middle term, negative 2n. All right. Now, that was section 510.